and welcome. I am trying to learn Heliology today, Algol systems. And after we've done that, we're gonna do wrist training. And if you participate in the wrist training, then it's better your own risk. Algol systems. About 93 light years away in the constellation of Perseus exists a famous interacting star system called Beta Persei or Algol. Okay. We did it in astronomy or space science, actually. Now, what was it? There's a famous interacting star system called Beta Persei or Algol. Okay, Beta Persei or Algol is within the Perseus constellation, 93 light years away from the Earth. The larger but dimmer of Algol's players is an orange subgiant. So an orange subgiant. Its smaller partner is a blue star on the main sequence. Orange subgiant and a blue star on main sequence. Algol's two components swing around each other with unceasing regularity once every 2.86 days. Okay, these two stars, the blue one, the blue subgiant, and the orange subgiant, blue main sequence, are orbiting each other with 2.86 with a regularity of 2.86 days. Seen from Earth, Algol's orbital plane is almost edge-on. So twice every 2.86 days, an alignment occurs. Twice every 2.86 days, an alignment occurs. Of what? With whom? In the same way that the moon sometimes eclipses the sun, the larger star partially eclipses its smaller cousin. So seen from Earth, Algol's orbital plane is almost edge-on. So twice every... They say humans on Earth see off-it orbit, not the side, or we're circling each other on the side, but they see the edge of it. So we're circling not that way, the other one, but that way. And almost twice a day, one is eclipsing the other. Twice a day, an alignment occurs as the moon is sometimes eclipsing the sun. The larger star partially eclipses its smaller cousin. Outside of the eclipse, both stars are seen in their entirety, and the system appears as it brightens. During the eclipse, the subgiant blocks some of the blue stars light behind it, and the system dims. So one is sometimes stronger, more seen as the other one. Sometimes one is behind the other one during the eclipse, and then it gets dimmer, and then it's the other way around, and then they are better to see. Or one of them is better to see. About 10 hours later, the subgiant moves away and restores the system to its original intensity. Both next to each other. But sometimes they're behind each other, and then one of them is stronger shining and eclipsing the other one. Once the stars complete half a turn, a less significant secondary eclipse occurs as the hotter star partially blocks the counter one. Yes, we did it. We had this, that was eclipsing stars, I think was it called. So one is going in front, the other one, and then from time to time the more dimmer one is visible, and the light is blocked out, and then it can be the other way around. Algol is therefore an eclipsing binary. In fact, it was the first eclipsing binary star ever recorded in 1669. Cataclysmic binaries, X-ray binaries, and RSCVN stars often exhibit eclipses too. This prototype is but one among hundreds of Algol binaries that show the same behavior. A general constant brightness for the majority of the orbital period, then a pronounced dip in intensity. There was a little illustration that was saying right after that dip in intensity it is the strongest. I think it was that way around, it was a bit confusing. It is when that moment the strongest. The dip in intensity is attributed to an eclipse of a brighter and hotter primary star by a cooler and dimmer secondary. Algol's are semi-detached systems. Okay. So it's just one with the other one. And also the other ones which we had in the previous part already, the RC, CVNs and the external binaries and cataclysmic binaries, sometimes doing the same, but one is eclipsing the other one. Algols are semi-detached systems in which the stellar separation is so tight that the gravitational pull of a primary on the secondary distorts the latter into an egg-shaped, as occurs in cataclysmic binaries or LMXBs. However, there is no accretion disk. So no accretion disk. One is bringing the other one in an egg shape. I think the red one should be an egg shape. The distorted orange star's atmosphere flows away from it and impacts the blue star directly on its equator, where the impacting gas is flung off, a bit like water hitting a spinning ball, to form a messy and tenuous flowing orbit around the blue star. So it comes to the blue star, and then it goes just around it, to form a messy and tenuous flowing orbit. So there is something going over, but not so much. And it is, for whatever reason, this time not as X-rays propelled out, but just going around it, like frizzling water in a pen, which is not a good idea. The gas is flung off, a bit like water hitting a spinning ball. I don't know what it is. To form a messy and tenuous flowing orbit around the blue star. We have a second. Yeah. From Earth, algal binaries are always seen edge on to their orbital plane. Is that the name for? They are called algals because... No, I don't think that is for me. Algal, that is just the one algal. And other ones are just as well eclipsing binaries, but they're not all called algals. From Earth, algal binaries are always seen edge on to the orbital plane. Maybe. However, in this depiction, we see an algal system from a slightly oblique angle and can witness the messy flow of turbulent gas that surrounds the hot top of the two stars. So the shot is that they painted it from the other side, so that we can imagine it better. That was the heliology part. If you were here for heliology, you can go directly to the next part of heliology, where we will continue with heliology. If you stay here and participate in the wrist training, then is that at your own risk. Good and still, stand arms up, hands from the fists, and bring them down. And up. Hands like that, in and out. We're having 3 routes. Hands like that, in and out. The first one is that we're stopping immediately as soon as there's pain. The second one is that we're going only as far as you can go with a little bit of effort. Open. And the third one is that we're not overdoing it, we just want to strengthen, not to exhaust. Hands out, down, and up. And hands like that, and in, up, out. One hand next to the body, down and press on the inside. And from the other side, top and bottom, change, and just press, release, press, release, and press, and press with fingertips on top of fingernails of the other hand, close again. And with the other hand, open, close. And both hands up and bend the middle knuckles. Up again and close. One more time. Hold it a bit. Up again. We're going to take a break. Hands up, down with flat fingers, up with strong fists. Straighten one arm, try to flex the biceps, hand into extension, press against the back of the flat fingers. Change. Other arm out, try to flex the biceps, hand into extension, press against the back of the fingers. And Both hands up and flare them cousin. Both arms up, strong fists into flexion without extension, flat fingers. In strong fists flexion, out extension. And both hands up and claw them, try to flap them apart. Open and claw. Open and claw. And now, long arms, strong fists, and into flexion with the hands. Out extension, flat fingers. Again in. And out. One more round. And now you can use a sock. Have it with a long arm at the outside, let it fall down and try to catch it again. And on the other side. And now go with moderate pressure of the middle part of the lower arm. And also on the other side. And first post for Wristtraining. I thank you very much and until next time.